Okay, fossils. And this is this is early paleontologists. Those are people that study fossils, excavating a T-Rex. Okay, in Alberta's Badlands. So that would be in Brooks area, Dinosaur Provincial Park, that area. So fossils, again, we said are direct evidence. Okay, that's the video of the whodunit. And they're just mineralized remains in rock or actual remains. Okay, the older the fossil, the lower down it is. So Badlands are a good place because they're so eroded. If you're being down to Drumheller, you go down. The deeper you go, the older you go. Okay, so why this is important is transitional forms. And this video um, is absolutely critical. I really want you to watch this video here. It's fascinating because it provides evidence of transitional forms with some species. Archaeopteryx is a very interesting case study of this. So fossil records should produce intermediate forms, organisms that show transitions from one group to another, otherwise known as missing links. Okay. Now we want to be a bit careful about this because remember I said that really there are common ancestors. We share common ancestors. There's no missing link between, say, humans and monkeys, in the sense that there's a line going from humans to monkeys. No, the missing links, when we talk about missing links, is more recent common ancestors, and that those are being found all the time in parts of Africa, especially Tanzania, for humans. Transitional forms represent successful changes in organisms over a long period of time. Now, one of the most famous case studies of this, apart from the birds, is horses. And another interesting one is whales. Check it out. We've got all these fossil evidence. Oh, look. They share a common ancestor with a wolf-like creature dating back 52 million years ago. Is uh, the baleen and the toothed whales. Okay. So that's interesting. All of this showing these transitional forms that when we talk about the wolves of the sea being killer whales, they literally have ancestors that were wolves that were able to exploit a new niche in oceans. Okay, now the horses we're going to get back to because it's a very, very interesting case study. Relative dating, um, we use what's called index fossils. Okay, easily distinguishable fossils that occur in certain time periods. Appearance of an index fossil um, indicates that rocks were deposited at the same time. So if I see this fossil in Canada and I find this fossil in Africa and Europe, that tells me that they were easily identifiable and they were deposited at about the same time. But that's relative. It's relative to what? This is older than that fossil. Okay, law of superposition. The deeper you go, the older the fossils. Okay, that's different from radiometric dating. Actual age of a specimen is determined using radioactive elements. Radiocarbon uses carbon-14 of many ancient forms. It's got a half-life of 5,700 years. But there's some limits to this. Used to date fossils up to 50,000 years, not very old in terms of evolutionary terms. Cannot be used to date the majority of life forms that were soft-bodied at the Cambrian explosion 300 million years ago. Now, this idea of half-life, you might have seen this before, and this is uranium. It's got a very big half-life, okay? 4.5 billion years when half of it degrades, okay? So the first half-life, if this is your chunk of, say, uranium, half of it will deteriorate into lead, 206, in 4.5 billion years. Half of it will deteriorate. The second, though, The second half-life, that's the first half-life. The second half-life, you're gonna have half of the half deteriorating, okay? So now I've only got 1/4 of it. So in the second half-life, only a quarter of my original parent material is left. And what we call this, that 3/4 that's left over, this part right here, this is called the daughter material. Okay, so this is fairly abstract. Let's make it simple. Um, Here we go. I'll take a look at this saber-toothed tiger. Okay, when it died, 100% of it was carbon-14. Now, what does that mean? Okay, well, um, I'm going to use me as an example. Okay, this morning I ate my cornflakes. Okay, there's the sun shining, and it converted my cornflakes from it fixed carbon in the Calvin cycle to make an edible form of carbon, and I took that into my body. A very, very small amount of this carbon dioxide is carbon 14. Most of it is carbon 12. Most carbon is carbon 12. This is stable, but this stuff has a half-life of 5,730 years. That means half of it will decompose into, I think it's nitrogen, okay, every 5,730 years. Okay, so there I am. Okay, I'm eating my cornflakes, and okay, I'm wearing a skirt, whatever. Okay, a terrible thing happens to me. I die. I get buried. Do I get to eat any more of my cornflakes? No. So I stop bringing carbon 14 into my body, and that carbon 14 decomposes. Well, let's say now that somebody digs me up, okay, and takes a bone out of my body and checks it for carbon 14. If they found, if this was my bone before I died, and I had a whole bunch of carbon 14 in it, this is my bone after I died, I only had half the amount of carbon 14 in it. That would tell me that this guy, me, has been dead for 5,730 years. But if it had a quarter of it, then I would have to have died for 2 half-lives, and I would be 10,000, 11,460 years old, okay? So that's how they radio date. They dig up a fossil, and they can figure out how much carbon-14 is left in it and compare it to the half-life. Okay, so do this one on horses, okay? You're gonna do a little bit comparative anatomy on horses. And what you see here is the dawn of the horse was five-toed. It was about a meter tall, epiphysis, eohippus rather, okay, and it started getting bigger. And notice what happened to the toes. They become um, these these hoofs, coffin bone, and so on and so forth. A hock is one of those vestigial structures is left over one of the toes. Look at the size of the skull as it changed from very small to large. And what was happening there is that the prairies, we were going from a forest environment to the prairies, and that changed the selection pressures. All of a sudden, these little guys that could hide now are on the open prairies, they died off. Those that happened to be born larger could outrun their prey. And they needed hoofs, not little toes, to be able to run fast. Okay, so different selection pressures as we went from a forest, uh, very hot, swampy areas, carboniferous, to the present day. Okay, we'll end it with that.